So tell me how it's different from the infrastructure perspective. So when you said that when you have a dedicated architecture for inference versus training, what
Yeah.
actually what is the baggage that training brings along that you don't need in inference, and what are the things that you need in inference that you don't get in the other architectures that are tuned for training?
Yeah. So at a very high level, Seth, I think it's performance versus efficiency, right? And I'll break it down for you as I answer that question. So what I mean by that is when you look at training, training is fundamentally a performance-oriented workload, which is, so there's a lot of emphasis on scale and performance. And, it's all about training a model as fast as you can train the model, because the longer it takes to train a model, the more dollars you spend. So people are trying to train it as fast as possible, which is all about performance. How quickly can you get this done? Lots of compute has to be thrown at the problem. The models, as they got bigger and bigger, you needed to support a lot of scale out. So you need to support a lot of networking across multiple. So there's thousands of GPUs these days to train an AI model, of typically a frontier model, needs tens of thousands of GPUs. So how do you take tens of thousands of GPUs with lots of compute, connect them together using a lot of networking, then build all the orchestration software to support a workload that has to be broken across all these different GPUs? They're all supposed to be kept in sync so that as the model is training, different parts of the model are all kept in sync. There is just a lot of software orchestration, a lot of networking, a lot of compute that has to be. And then, with it comes the second order challenges, which is, how do you cool all those GPUs and how do you supply power to all those GPUs? And so the scale of the problem is very, very different. This problem is very, very different. It's a very costly problem for most companies. And there's a lot of, bleeding edge tech that has to be introduced into the solution to keep that going, right? Now, inference is very, very different because, again, inference is an efficiency problem. So there, you're not necessarily building, a solution with thousands and thousands of GPUs. What you're trying to do is you're taking a model that has already been trained. In many cases, you're distilling that model down. So you are actually kind of shrinking it in size. And what people are finding out that a model that is distilled down from a very large model tends to be as capable and can do most tasks really well.